In these problems, when you have integrals with tan and sec, the solution to this, there are two types of them. One of them, this is what we're doing here, it's when at least one from the exponents, both m or n, at least one is even. So let's solve an example together. So let's say we have tan 3x and then secant 4x dx. So this one is even, so we can use this procedure. So how do we do this? Well, the first step is getting rid of the dx part and get the du in. So the way for us to solve it is by just noticing that because we have 4 here and we need 2, so we take 2 out. So the expression now is tan 3x secant square x, and then the remaining part, let's leave it as is for now, but just know that now the du is solved because we have a secant squared x here. So let me just make a note there real quick. So this part is du, and now we need to solve for this part that is u. And we have two expressions to help us do that. We have one for u, which is tan x, and we have one that has secant squared x is equal to 1 plus tan squared of x. So let's simplify this to our advantage. So tan x is u to the third power, and secant squared x, as we see here, it's 1 plus u to the second power. So it's multiplied by 1 plus u squared. And the remaining part, we already know that is du. So if we expand the terms, we get u3 plus u5. Remember, it's the same base. You add the exponents. So u3, u5. And then it's the same old. So 1 divided by 4. And the other one, it's u6 divided by 6. So now we need to just change the terms back to 10. And we get that the final result is 1 divided by 4 tan 4x plus 1 divided by 6 tan 6x plus c. This is your final answer. So let's say now we have tan 5x secant 6x dx. Same as before, u is equal to tan x, du is equal to secant square x, and we also know that secant square x is the same as 1 plus tan square x. So we take the requirement in order to get the du solved. So this is the same thing as having tan 5x secant 4x, and then we have secant 2x dx. So this one is du. And now we're going to work on these two in order to solve for u. So the first one is 5, so we can make the change directly. So it's u5. Now times this one to the fourth power. So if you make the change in this expression, it's secant 4x. It's equal to 1 plus tan square x, but squared. Or in other words, the same thing as saying 1 plus u squared, this all squared. So we can even further simplify this expression before we get it into the integral. So this is 1 plus u squared times the same. So this is the same thing as saying 1 plus u squared plus u squared plus u to the fourth power, or in other words, 1 plus 2u to the second power plus u to the fourth power. So substituting it back here, we get 1 plus 2u squared plus u to the fourth power du. So if we keep further distributing the terms, we get 1 5 plus 2u 7 plus u 9 du. So substituting it back, and now we just need to solve for the integral. So this is 1 divided by 6 u6 plus 2 divided by 8 u8 plus 1 divided by 10 u10. getting the terms back together. So it's 1 6, u is 10x, so 10 6x plus 2 divided by 8 is 1 4. So 1 4, 10 8x plus 1 divided by 10, 10 10x plus c. This is your final answer.